Hey guys, it's Mr. Katz. I'm here with period 5. We're going to talk about the square rooting method when you don't have something that's a perfect square. And I want to be specific about this, that I would never use Tia's method or the square rooting methods to solve a problem like this. So what you would do is you need to turn this into a perfect square. And to do that, we want to make sure that we know that we have to change this c in order to make this a perfect square. Just a reminder about perfect squares. Perfect squares are like x plus 3 squared, which is x plus 3 times x plus 3. And another perfect square could be x minus 3 squared, which is x minus 3 times x minus 3. If you were to multiply these two binomials, you end up with this. You'll notice a couple things about them. One, the last term is always going to be positive. So that's important to know. And the other thing is that if you take the square root of a and you take the square root of c and you multiply it by 2, you always end up with that middle term. Same thing here. 1 times 3 times 2 will always get you that middle term. You really don't have to worry about the negative or the positive. Think of it as just a 6, because if it was a negative 6, you know that it's just going to be x minus 3 times x minus 3. If it's a plus sign, it's x plus 3 times x plus 3. So that fact that reminded you about perfect squares helps you in doing a problem like this. And again, I'll say that I would never usually do this for a problem like this. I would say factor if you can, or use the quadratic formula. So to turn this into a perfect square, remember, we know that the square root of this number, which is 1, and the square root of the c, which we don't really know what it is yet, times 2 will get you this 4. So we have to kind of say to ourselves, 1 times 2 times what number gets us 4? And you should have said that the number that this one has to be is a 2. So what number would we have to square root to get a 2? Well, the only thing that gets you a 2 if you square root it is the 4. So that means that this last number has to be a 4. But right now it's a negative 8. So what can we do to make it a positive 4? Well, we can add 12. And if we add 12, you get x squared plus 4x plus 4. Now we have a perfect square, not the difference of two squares, but a perfect square trinomial. So this would factor into x plus 2 times x plus 2, which is just x plus 2 squared. So I did my job. I took this equation, I kind of squared it. But remember, in the beginning, we added a 12. And we still want this. We don't really want to change the equation. So we want to even it out at the end by subtracting 12. And remember, this whole thing equals 0. So now I was able to write something in standard form, in vertex form. The other way you could have done this is if you would have found the vertex by doing negative b over 2a, you would have found that the vertex was, the x-coordinate was a positive 2. And if you plugged a 2 into this equation, you would have gotten the y-coordinate as a negative 12. And knowing that x is 2 and y is negative 12, and knowing that the dilation, the thing in front of the x squared, is a 1, so that means there's just like a 1 in front over here, you could have also gotten this vertex form that way. But now we have it in vertex form, so we can now solve it by square rooting both sides. But first we have to, this is the one method where you have to actually not have it equal 0. You want to move the 12 over. And now, since I have a whole side being squared, I can square root this side and square root this side. And I'm going to show my work a little bit above here, but this would normally go below. The square root and square of x plus 2 just leaves us with x plus 2. And the square root of 12 does not come out evenly. It doesn't come out to be a whole number. So we have to remember, though, it's going to be a positive and negative square root of 12, whatever that becomes. Now, to finish solving for x, I would subtract 2 on both sides. So now we get our two answers. X is going to equal the positive value of the square root of 12 minus 2. And x is going to also equal the negative square root of 12 minus 2. Notice that you're still squaring a 12, but once you get your answer, you're going to have a negative on it, minus 2. And when you put this in your calculator, those would be your two answers. And that's how you would use the square root method to solve something that's not originally as a square root.